Alright, welcome back for Chapter 8. So we're talking about subnetting. We did do some IP addressing. We did show you the math for doing subnetting. Now we're going to talk about why we subnet. This is an important part of what we do as a networker. When you have a network, you have the whole network as part of a broadcast domain. You might have realized this from earlier chapters. Now, that's good and bad. The bad part is, if they get too big, a lot of your protocols do broadcasting, which is updates or other things that send to all devices. This can take up a lot of your network and really slow it down. So if you break it down into two smaller subnets, like here, you see here, with 200 users or 200 devices or whatever, you don't have as big broadcasting, so you don't get that much of that overhead. So when you do this, break this down though, you want to do it in a logical reason. So you might do it by floors, as they do it in this case. You might do it by departments, human resources, because typically, they're grouped together for a reason. There's a logical reason behind it. Or all devices, all servers, all printers, whatever works for you. You'll have your reasons for it, and your department will set them up, particularly somebody who has a lot of experience in this to do that. Now, to take this down again and go review a little bit of review, your subnet mask is in decimal form, but it really works best in binary. So you have your ends, your host, the ones, the host, ends, the network, ones, the network, zeros, the host, H, the host, or whatever. Hosts are your devices, network is the address for the network group of devices, group hosts. This will tell you how you break these down. Now, these are your classful or default subnet mask. Again, it breaks it down to binary, the ranges, the broadcast. The broadcast is for all devices within this range, or all hosts within this range. So you have them too big and get a lot of broadcasts. And then it talks a little bit about subnetting down. So we start tacking on 16 here. The subnet mask changes to 24, and you start tacking on here. Now you're starting to get different subnets. So let's talk a little bit about how that works. Now, what you did first was class full, the old-fashioned way. But that didn't work because we needed more IP addresses. So we went to this class list. We needed to break it down a little bit more. So now with class list, we get these oddball subnet mask numbers. Basically, you start taking bits out. You get this prefix length, you get number of subnets, number of hosts. Again, you've done this stuff before. Now we're explaining why. Which should hopefully help you. So I suggest you watch the video, watch the other video. This one talks about the subnetting, doing the process. This one tells you some of the tricks and some of the, it's math, so you'll start noticing patterns in this. And they'll tell you why you have those patterns and what to look for. And again, you have your network portion, you have your host portion. You have address, your address and your mask. Your mask tells you where that breakoff between the host portion, network portion are on your address. That's its purpose. So when you need to start making these subnets, you're doing what we call borrowing from the network, from the host to make a network. So you borrow one binary, so we got to break it into binary to keep this one bit, one in the binary to keep the way to do it. Put in the binary so you can keep track of this stuff. You get your two subnets. You're done. You end up with this as your subnet mask with two networks with 192.168.1.0/25, which tells you that this is actually over on the network side, not the host side, and 192.168.1.28/25, which is still that one's over on the network side, not the host side anymore. And yes, you'll have, the mask will be the same as the other net. In some cases it will, because it breaks down with these bits, or what's important, as defining the cutoff. So, say in this example, they want to have two subnets. Because you have two interfaces here, two router interfaces here. Over the process, network address. So for host, this is the network address. The whole part here is network address. This is the host portion. First host is the first one with a number. Last host is everything but the last one filled out. And the broadcast is all these in one. So host, the network address has all the hosts as 0. Broadcast setup, all the hosts is 1. First host is immediately after the network address, and the last host is immediately before the broadcast address. Again, the same case here. But you notice they changed this borrowed bit number. That's where you get the differences, where that borrowed bit, that subnet bit. You might even want to take a line down the middle here and call this the subnet section right here. And now you see how you get, starts with 128 instead of 0. Goes to 225 instead of 127 over here. And moving on, this is how you put it into play. IP address. It's the same way you put your network address in as you always have, but now you actually have a chosen structure on your part. In the same case here, you just need to have subnet mask properly, and the default gateway, well, you'll have that assigned to a particular device. Again, we'll have a little video walking you through it. Yay! Now there's math involved in this. Yep, there's got to be math. So 2 to the n, which is the number of bits borrowed. So you know how many networks you can get by taking 2 times whatever bits you borrowed. So take 2 to the power of how many bits you borrowed. So it's 2, 4, 8, 16, 32, 64. There you go. And you can see how the progression, how it works. You see the pattern. Now, how do you know how many hosts you're getting? You take 2 to the n minus 2. Why do you minus 2? You have one of those hosts is going to be for your network address, all the zeros, and one's going to be for the broadcast address, all the ones. You always have to subtract those out. If you have them in there, you're going to have problems. This is how many hosts you have. This is how many valid hosts per subnet you have. Yeah, great. All right. Create a solar subnet. Same things you did with the 2, except that you're borrowing 2 bits instead of 1 bit. So here you go. 1, 0, 0, 0, 1, 1, 0, 1, 1. The same process. You really do need to break it down into binary. Keep track of this stuff. I really highly suggest that. Again, you do the math, figure it out. This takes practice to do. I will probably give you more worksheets later on for practice. Probably in quarter 3, just to get a refresher, so it sticks in your head a little bit. Again, here also it gives you the network, first, last, and broadcast. In the real world, you will have spreadsheets or whatever way you keep track of the records. You will keep track of these records. This is what you need to do. In this case, you're only using 3 of these 4 subnets, but they did break into 4 subnets. There's something called variable length subnetting, but we're not going to get into that in this class. Say yes. Be happy. Trust me, it's a pain. Again, a video to watch 4 way. And then an 8th way one. Oof. All it is, you're just borrowing 1 more bit. And it takes a little bit longer process. And I'm going to stop here and we'll go to another class later.